This video is looking at the traditional method for testing a hypothesis of a mean. So first of all, the steps for using the traditional method to test a hypothesis are shown here. So first, identify the claim and put it in symbolic form. Second, use that symbolic form, state the null and alternate hypotheses. So the difference between those two, remember, null is the one that has equality in it, alternate does not have equality in it. Decide on alpha. Often in the text questions this is given. Determine on the test statistic. So this depends on which scenario we're talking about, but first we're going to be looking at testing a mean. So there's two possible calculations for that. Our z-score calculation, which you'll notice is the central limit theorem formula, if we know sigma, or our t-score calculation, which is similar, but instead of our sigma we've got s, if we do not know that value. Once we figured out the test statistic, we also figure out the critical value and critical region using our tables or using Excel. And we reject the null hypothesis if our test statistic falls in our critical region. We do not reject it if it's not in the critical region. So number 5 is our decision step. And our last step, not to be forgotten, is a statement addressing the original claim or question. So one thing that sometimes people mix up in these formulas is that we have two means, right? We have x bar and we have mu x bar. So x bar is our sample mean and mu x bar is the one about our population, so it's the one that's claimed. So be careful about those two. So let's look at a couple of examples. First example, the drilling manager claims his technologists work a total of 500 hours on an average week with a standard deviation of 12. To test the hypothesis, a random sample of 50 weeks over the last 5 years is selected. It has a mean of 498.5 hours. Use a 5% significance level. Test the manager's claim that the mean time worked is 500 hours. Use 12 hours for the population standard deviation. So first thing is identify all the things that you know in this situation. So we can see that our claim is that we have 500 hours on an average week. So another way of saying that is our claim is that the mean is 500 hours. Oh, I see why it's doing this on me. And then we have that the standard deviation is 12 hours, and we're specifically told in the question, use 12 hours for the population standard deviation. So that's really important that we pay attention to, do we have a population or do we have a sample? So this one is sigma. And then we have a sample is over 50 weeks, so that's how many weeks are in our sample, because this is hours per week. So that's going to be our n. And we have another mean, but this one's the mean from the sample, so this one's going to be our x bar. And the last piece of information we've got here is this 5%, so that's going to be our significance level, our alpha. So we can take that and now look at all those pieces of the formal hypothesis test. So the first step was identify the claim. We identified that the claim was that the mean equals 500 hours. Note we also have to decide, is that the alternate or the null hypothesis? So it's got an equality in it. It's going to be the null hypothesis. So the opposite to that, our alternate, is going to be that it does not equal 500 hours. So which kind of test are we looking at in terms of left, right, or two-tailed? This is definitely a two-tailed test. Move that over. So if we look at all our variables that we identified, tells us a few things. From there we can calculate either our critical value or our test statistic. Notice we can calculate them in either order because we're comparing them to each other. So it doesn't matter which one you calculate first or which one you calculate second, as long as you calculate them both. So our test statistic, because we are looking at a claim about the mean and we do know the population standard deviation, we're going to use our z-score to calculate both our test statistic and our critical value. So the test statistic is the one we calculate with our formula. The critical value we have to look up. So this alpha equals 0.05 tells us something about our diagram. Specifically, it tells us that these two tails together are 5%. So each tail separately is 0.025. And so when you look that one up on your chart, you can either look up 0.025 or this side we'd be looking at 0.975. And we can see that the z-score on the one side is positive, on the other side is negative. We get 1.96 when we look that up in our chart. If we compare where our test statistic falls, negative 0.88, well, if this is 1.96, negative 0.8 is going to be about right here. Not in our critical region. Remember, the knots go together. So if it's not in the critical region, we do not reject, and there's not enough evidence. So let's write that all down. So the test stat is not in the critical region. Do not reject the null hypothesis. And our statement is going to say there is not enough evidence. Specifically in this case, we're not rejecting H0, right? So we're not rejecting that one, so there's not enough evidence, and that is our claim. So there's not enough evidence to reject the claim. Sorry, my typing's a little off here. And if we look at our numbers in this particular question, that makes sense. Our sample is 498.5. It's a little bit off from the mean, but we're basically saying this is not statistically different. It's reasonably close. And I see I missed one little thing we're going to fix here, and that is to identify which z-score we're talking about, right? So this was our z critical value, and this over here, where I put my line, is our z test statistic. So subscripts there help to indicate which one is which is a good idea. Okay, moving on to the next example. A website reports the average price for self-serve gasoline in Edmonton is $1.157 per liter. You believe the figure is higher for Calgary. You decide to test this and look up prices at 150 randomly chosen gas stations, and you get an average of $1.169 per liter. So does this data provide enough evidence to support the belief that the price is higher? And again, we're told use sigma, so we know that's the population standard deviation. So let's look at what we know here. So there's several pieces of information. When we're trying to identify the claim, if you do have a sentence that actually ends in a question mark, that's a good idea to use that to try and figure out what the claim is. So if we see what's in there, it says your belief that the average price is higher. So we can see that that claim is that the mean is higher, so greater than. So that's going to be H1, right? Because there's no equality in higher. So the alternate, if we're going with strictly the direct opposite of the claim, we would say less than or equal to. But often you will see these done with the other hypothesis. When our claim is the alternate hypothesis, you'll often see it used to say that the null hypothesis is just equality. And your textbook does use this notation. It doesn't really matter which way you write it as far as these two go in terms of your calculations. You're still going to come out to the same calculations, but we're always testing against the equality, which is why most texts will choose to say if our claim is the alternate, that the null hypothesis is just equals. If we're thinking of it as direct opposites, we would say less than or equal. If we're looking at the null hypothesis to identify whether this is left, right, or two-tailed, this doesn't affect that. So it is going to be, pointing to the right, a right-tailed test. So again, identifying all of our variables. Obviously, our standard deviation is 0.034. Alpha, our significance level, is given as 1%. Our sample mean is the mean from your 150 randomly chosen stations. Speaking of 150, that's our n. So there's our variables. Oops, didn't mean to make the question disappear. So again, we know our standard deviation. We're going to calculate z. And that's going to work out to be a fairly large test statistic of 4.32. If we compare that to our critical value, so again, we've got to put these values on our chart. So our alpha we said was 0.01, so this is 0.01. We look up 0.99 using your chart or Excel. We come up with 2.33 for our critical value. Now if we compare our 4.32, that's saying it's going to be like way out here in our chart. So it's definitely in the critical region. So we're going to reject the null hypothesis, which means we're going to support the claim, right? If we're saying that this one here is wrong, then we're saying that this one here is right, because they're opposites. So reject the null hypothesis. Also says support the alternate. And remember, we're doing this because the test statistic is in the critical region. And so our conclusion, again, addressing that original claim, right, answering the question, does the data support your belief? We would say there is enough evidence to support the claim that the mean price is higher than 1.157 per liter in Calgary. So that's our formal traditional test using the Z-score on the mean.